All right, let's finish up with number 22. The graph of the function f above consists of three line segments. Let g be the function given by g of x equals the integral from -4 to x of f of t dt. For each of g of -1, g prime of -1, and g double prime of -1, find the value or state that it does not exist. So let's start with g of -1. So g of -1, I'm just going to plug it in here, which plugs in for the x. So this is the integral from -4 to -1 of f of t dt. Let's scroll up and take a look. From -4 to -1, we see that this function is a trapezoid. So it's going to be 1/2 the height, which will be 3, times the sum of the bases, which are -2 and -3. So 1/2 times the height times the sum of the bases. -2 and -3 gives us -5, times 3 is -15 over 2, or -7.5. Just checking to make sure this is below the x-axis, so a negative area is what we want. G prime of -1. That means we want the derivative with respect to x of this. I'm going to start with finding just g prime of x first. And so the derivative of the integral, this is that fundamental theorem of calculus part 2, where they cancel out and we get f of x. So g prime of -1 is equal to f of -1. And we see that right up here on the graph. F of -1 is -2. G double prime of of x, let's say, is f prime of x. So g double prime of -1 is f prime of -1, and the slope at -1 is undefined because of a corner, so does not exist, corner. All right, for the function g defined in part A, find the x-coordinate of each point of inflection. So where does a point of inflection occur? Point of inflections occur when g prime, which is f, changes from increasing to decreasing, or decreasing to increasing. So if I scan and I look up at the graph of f, the function is increasing, 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 and here is a change right here from increasing to decreasing, and then it decreases the rest of the time. So at x equals 1, there is a point of inflection. So at x equals 1. All right, C, let h be the function given by this. Now, first thing is this. Notice the only difference between h and g is the lower bound. Up here, g, it's -4 to x. On c, on h of x, it's from 3 to x. The only difference is that, and that doesn't have any bearing on most of the calculations. Very rarely will it come into play. The reason for the change of function, I was looking up, I saw one example of this where they had actually switched the bounds. So the first step in using this function would have been to swap them using the negative of the integral and everything. So, but that's not what happens on this one. So really, we could almost continue with just g of x in this problem. But anyway, let h be the function given by h of x equals the integral from 3 to x of f of t. Find all values of x in the closed interval for which h of x is 0. So again, what we're looking for is when is the area between 3 and anything equal to 0? Well, the first thing would be 3, because the integral from 3 to 3 is going to be 0. So that's probably the simplest answer to get. But where else is it going to be 0? So let's take a look back at the graph. So if I start shading in at -3, now it says from -3 to x, so we are going backwards. So because we're going backwards here, this negative area is actually positive, and then the positive area is actually negative, and so on and so forth, because normally area underneath is negative if we're moving left to right. But if we're moving right to left, it is the opposite of that, so it would be positive. So we have positive area here, and that forms this triangle. So when I create another triangle that's exactly the same, that is, that happens here at 1, we have a positive and a negative area that balances out. So at x equals 1, we would have another one. And then notice as well, we have more negative area, and then we have an equal opposite area. So at x equals -1 as well. So for part C, it's at x equals 3 and at x equals -1 and +1. And we can say due to congruent, well, we could say it this way, congruent opposite areas. All right, and then finally D for the function, find all the intervals on which h is decreasing. So h is decreasing implies that h prime, and again, the derivative of all of this would just be f of x. So where f is less than 0. And so if we scroll up, the function f is less than 0 from -4 to 0 and from 2 to 3. And that finishes off the FRQ. I hope it's helpful. Good luck on the test.